Question 12. Diagram shows a Horcrux. ABC is an equilateral triangle and D is the midpoint of BC. AD is perpendicular, so they're not shown, but obviously this means that they are right angles. The circle K touches the three sides of ABC. Alright, part A, write the correct transformation into the box below. Be as specific as you can. So ABD, that's basically the triangle on the left hand side there. ABD, that triangle there, is the image of ACD, the right hand side triangle. Under what? Well, it's effectively a mirrored image. So what that is axial symmetry about the line AD. For example, a good example of that is a letter that's not symmetrical. So if you take P there, if this is the line AB, axial symmetry, the way this will work out will be there. So you've got like a mirrored image. Okay, a mirrored image. So it's axial symmetry about the line AD, which is the line going straight down through the middle. Okay, on to part B. AD is equal to 10. Let's just back up here. AD is the line that goes straight down the middle. Now it's given to us here in part B as 10 centimeters. Work out the line AB, which is the left-hand side there, the line I've called X. You can see up in the main diagram, the left-hand side line. Okay, so there's kind of two ways you could do this now. So this triangle, if it was extended across the way there and up, the bottom line would be 10, and this is the point D. We were also told that that was the midpoint, meaning we could just say straight away that that line there is 5. That's one way you could do it and use Pythagoras to work out the hypotenuse. The other way I did it was, I said we were told it was an equilateral triangle, so all the angles are the same size, they are 60 degrees. So this is the way that I'm doing it. I'm saying that that angle is 60 degrees. We know that this side opposite is 10, so we're going to work out the hypotenuse basically using sine. So sine 60 is opposite over the hypotenuse, 10 over x. And sine 60 root 3 over 2 is equal to 10 over x. Cross multiplying then, we get x times root 3 is equal to 10 times 2. So 20 is equal to root 3 times x. So x by itself is equal to, dividing across by root 3, x is equal to 20 divided by root 3, which is 11.5 centimeters. Now for anyone that did this question the first way, in other words, using the bottom line as 5, you should have got an answer fairly close to that. Perhaps with decimals, if you're rounding up or down, perhaps you might get a slightly different answer, but it should be very, very close to 11.5 anyways. Okay, so that's that part B there. The question asked obviously to find AB. I just called it X. Obviously X is equal to AB. Didn't say that, but it's probably obvious. Okay, we move on to part C. The diagram below shows the triangle ABC. Construct the rest of the Horcrux using the following facts. So we basically have to construct the circle that touches all sides. The line AD is the perpendicular bisector of BC. Okay, that's a point that we basically need to construct. The center of the circle K is the point of intersection of AD and the bisector of the angle B, the bottom left angle there. Okay, so we do this step by step. I'm going to move some of this out of the way now for a moment. Now we're just focusing on bisecting BC at the moment. The question obviously said there, point 1, the line AD is the bisector of BC. So first thing we need to do is bisect BC. Here we go over here. We place the point of the compass at B and we scribe an arc from B. Now, the important part to know, it has to be longer than, if you scribe an arc in here and then you move over to C and you scribe another arc, they obviously won't intersect. So the width of the compass has to be more than halfway. So if you're starting at B, I would go over to about there and then scribe your arc above and below BC. Okay. Part 2, place the point of the compass on A now and scribe an arc from A and below the line, above and below the line BC. So you're seeing that there as the pink arcs, as it were. So they intersect, the pink and the greens lines, they intersect above and below the line. The 2 points where they intersect, I'm just going to highlight them there in yellow, that point there and that point there. That is, you connect those up. I've joined it with a blue line there, and that is the perpendicular bisector to BC. In other words, the blue line is at 90 degrees from BC and it goes straight through the middle of BC. Now there is the section to do with constructions, and it's a very good video, and that what I've just done there is the very first construction that I've done there. Okay, so you can go back over that in the notes as well. Okay, the second part up here, so it says the center of the circle K is the point of the intersection of the line AD that we've just drawn in and the bisector of the angle B. So we now need to move down here to the bottom left corner here and bisect the angle B. Now, as you can see, I've just added in a couple of more construction lines there, and I will speak about them now in a moment. So we're starting here, which is effectively point 2. This is about bisecting the angle. Okay, step 1, place the point of the compass on the point B, scribe the yellow arc. Okay, there's no real, doesn't matter how long or how short the arc is. You scribe an arc from the point here on BC over to the other line there, AB. Now, where I've put the 2 pink markers, we're now basically moving on to the next point, which is point 2. Put the point of the compass where the yellow arc meets the line BC. That's the little purple mark there. And we scribe another arc up there, which is the blue arc. And then moving to point 3, put the point on the compass where the yellow arc meets the line AB, which is effectively, I just put a purple spot there. That's that purple spot there. And you scribe another arc. I've that done there in black. Okay, so these 2 points intersect at a point there. I'll just call that the orange point where they intersect. And I've said draw a red line to connect the point B, which is the angle B, to where the blue and the black arcs intersect. In other words, where I've put the orange dot over there on the diagram. And the last part involved there then is point number 5, and it just says there, extend this line, the red line it should say there, sorry, that's the, oh, I fixed it there. So we're extending the red line to the blue line to find the center of the circle. So you can just see there, I've extended this red line that was going up there, it's going all the way up there to where it hits the blue line there. That's the blue line that we did earlier. Now I'm just going to put a green highlight mark there. That is effectively in the diagram up here at the very top of this question. That is the point there. That is the circle, the center of the circle K. See it there on our diagram there as well. Okay. And the last part then was that we drew the circle. Okay. So how we work out the radius of this circle, you can use the distance. I'll just add it in there from the green point down there to this. Now perhaps this might not look right on my diagram, but it was as accurate as I could do it. Okay, so we'll just add in the circle here now. Now, just add that in up here. And the idea is that this circle will touch each side of the triangle equally. Hopefully there's as accurate as I can get it there now. So that's that, okay? The circle or the Horcrux is seen in purple, okay? That's perfect. Now, people might point out that this point here, the green point, the center of the circle, perhaps the distances may not look the same there. Those radiuses, perhaps people might say, well, they don't look the same. That couldn't be right. That's just the way I did it on the computer. Okay, when you draw it out with your actual constructions, it will hopefully work out properly for you, maybe neater than my one. This construction, this second one here, bisecting an angle, that is there in the notes as well, in the geometry section, constructions. So please refer to that. And that's the end of that question there.